This is the last video on groups of the periodic table, and we're going to be looking at group 0, which are the noble gases. Just to remind you that elements are put in groups based on their physical and chemical properties, which means that the group 0 elements all have things in common in terms of their physical properties and in terms of their chemical properties, in terms of how they react. We're going to start by looking at their physical properties. So your group 0 elements right over on the right hand side, they are non-metals. So I have them here. Over on the right hand side, helium, neon, argon, krypton. They are all non-metals, and because they're non-metals, they've got properties similar to other non-metals. One of those properties is that they are poor conductors of electricity. Another property is that they've got low melting and boiling points. Okay, they're called the noble gases. They are all gases at room temperature, which means they all have low melting and boiling points. If we look at the trend in these physical properties, we can see that from helium, as you go down to neon, argon and krypton, that the melting points do increase. So if we're looking at these numbers, I know the numbers themselves are getting smaller, but they're also getting less negative. So minus 272 is a lower temperature than minus 157. So we can say that the melting points are increasing as you move down the group. The same can be said for the boiling points. Those numbers are getting less negative. So as you move down the group, those boiling points are increasing. And you will also see that the density increases as you move down the group. Okay, so there's three properties that increase as you move down the group. But what you will see is that even down here at krypton, the melting point and boiling point are still incredibly low. They are all gases at room temperature. Their uses, the uses of noble gases can be linked to their properties. In particular, we can look at density. So helium is less dense than air, and that means that helium is going to float on air. You know that from seeing helium balloons. Helium balloons always float on air, okay? But as well as being used in just normal birthday balloons, helium can be used in weather balloons. And these weather balloons will rise high up into the sky because they float on air, and they can be used then to detect changes in the weather. On the other hand, you've got something like krypton, which is, sorry, not krypton, we're going to talk about argon. Argon, which is more dense than air. Because it's more dense than air, it sinks below air. So argon, because it's more dense than air, will sink below air. And this is really useful in wine barrels. So if you have wine and you're trying to store it in a barrel, you don't want the wine to be able to react with the air at the very top of the barrel. So what they do is they put argon in. Argon will sink below the air, and you've got this layer of argon between the wine and the normal air. And that stops the wine reacting with the air, so it preserves the wine. So there are two uses of the noble gases that link directly to their density. Okay, another use, neon, you see neon in neon lights. So neon can be used in illuminated signs. As well as knowing their physical properties, you need to know their chemical properties. The noble gases all have a full outer shell. That is what they have in common. Because they already have a full outer shell, they don't need to lose or gain electrons, and that makes them very unreactive. Another word for unreactive is inert. And if we look at two examples, I've got helium here with 2 electrons in its outer shell. But for helium, the outer shell is the first shell, and the first shell can only hold 2 electrons, therefore helium has a full outer shell. For neon, it has got 8 electrons in the outer shell, its outer shell is the second shell, and the second shell can only hold 8 electrons. So that's 2 noble gases, both of them with a different number of electrons in their outer shell. But what they've got in common is that they both have full outer shells. And you would see the same if you continue down the group to krypton and to argon and to krypton. If we just look at an exam question on the noble gases, there's not really that much that you need to know about them. As I mentioned before, those boiling points, you don't need to know the numbers off by heart. You just need to know that as you move down the group, those boiling points are increasing. So if you're asked to predict the boiling point of argon, you just need a number that's bigger than minus 246, but smaller than minus 151. So I'm just going to go for minus 200 because that sits in between. Then it asks you to give a reason why group 0 elements are chemically inert. Inert means unreactive, and you're going to say the reason they're unreactive is because they already have a full outer shell. Okay, so that's pretty much all you need to know about the noble gases. Just know that their melting and boiling point increase as you move down the group. Know that they are inert or unreactive because they already have a full outer shell, and be able to give one or two uses of noble gases.